Take a look at this problem. The volume of a sample of gas is 750 milliliters at 75 degrees and 0.75 atmospheres. At what temperature in degrees Celsius will the sample occupy 1,000 liters, 1 liter under a pressure of 1 atmosphere? So, alright, first thing we need to do here is write down the information that we have. And what I normally do is, as I'm reading the equation, and whatever I come to first, that's what I will label first. So just want to make sure though that it is all together, they relate to each other. So first thing we have here is V1. The volume of sample of gas is 750 milliliters, so that's my V1. So that's 750 milliliters. I have at 75 degrees, so T1 is equal to 75 degrees Celsius, but this number needs to be converted to Kelvin, so we add 273, which is going to give us 348 Kelvin. Then and 0.75 atmosphere, so my P1 is equal to 0.750 atmosphere. It says at what temperature, so that's the second temperature I'm coming across, which is my question mark. In degrees Celsius, will the sample occupy 1 liter? So this is my volume 2, which is equal to 1 liter. But you notice that my first volume is 750 milliliters and my second volume is 1 liter. So this needs to be converted to milliliters. So this is equal to 1,000 milliliters under a pressure of 1 atmosphere. So P2 is equal to 1.0 atmosphere. So we have our equation. P1 V1 over T1 is equal to P2 V2 over T2. We want to solve this equation for T2. When we do that, we will have T2 is equal to P2 times V2 times T1 divided by P1 times V1. Once we've done that, we simply substitute the information back into the equation. So P2 is 1 atmosphere, V2 is 1,000 milliliters, T1 is equal to 348 Kelvin, P1 is equal to 0.75 atmospheres, and V1 is 750 milliliters. When we do that, we're only left with volume, or with temperature, which would be 619 Kelvin, and in degrees Celsius we would have 346 degrees C. Simply take 619 and subtract it from 273, and that will give us our answer for Kelvin. Alright, let's take a look at another problem. It says, what volume will 5.0 grams, alrighty,